Hello everybody, this is Mr. McNair, and this is a review of sections 8.1 through 8.3. Now in our book, chapter 8 is actually all about quadratics, and we know that a quadratic is any equation or function that has a highest exponent of 2. We say that has a degree of 2. We know that every time that you graph a quadratic, you will always get a parabola. A parabola is a U-shaped graph that can open upwards or downwards. It has a vertex, which is a highest or lowest point. We call that having a max or a min. So let's go ahead and get into this review. I picked a couple of problems that I think would be significant in the sections 8.1 through 8.3, especially when it comes to reviewing for your quiz. So this problem says, tell whether each function is quadratic. Explain. Now, here, once again, you want to look at since they're giving you equations or functions, you want to look at their highest exponent. Now in number 1, we see that there's a highest exponent of 2 already, but what I suggest that you always do is put the equation in standard form. Now standard form has to do with having y by itself on one side, and then from there you're going from, you order it so it goes from highest exponent to lowest. So here we do see that in standard form we have a highest exponent of 2, and because it has a highest exponent of 2, we know that this is quadratic. So yes, it is. Next one, in number 2, once again, I would suggest that you put it in standard form first. So we're going to get y by itself on this side. So we do that by subtracting x squared from both sides. Now, when you do that, the x squareds on the left cancel out, just leaving you with y. And on the right, you have a 4, and those x squareds actually cancel out as well. Okay? So, since when we put it in standard form, this equation does not have an x squared, this is not a quadratic. So, no. Now, if I was to ask you to tell whether a function is quadratic, and I don't give you a equation or function, I just give you a list of ordered pairs. Well, what I would suggest that you do first here is make a table. Make a table out of these values that I give you. All of our x values are -2, -1, 0, and 1. So I'm just going to go ahead and put those in our table. So our values are -2, -1, 0, and 1. And the corresponding y's are 12, 3, 0, and 3. So 12, 3, 0, 3. Now, in class, I told you guys that if they give you a table, that you could tell if a table represents a quadratic function if their second differences are constant. All right, so let's take a look at our differences here. From 12 to 3, we had to subtract 9. From 3 to 0, we had to subtract 3, and from 0 to 3, we had to add 3. These values down here are called our first differences, the first ones, okay? Now to find our second differences, we take the differences of the differences. So now we're going to go from and look at how did we go from -9 to -3? Well, we had to add 6. How did you go from -3 to +3? Again, we added 6. These values down here are our second differences. If the second differences are the same, they're constant, then we know that our table represents a quadratic function. And because these are both 6, we know that this represents a quadratic function. So yes. Now one thing that I neglected to mention at the beginning of this problem is that before you do your first and second differences, you always want to look at your spacing in the in your chart. Your x values have to be evenly spaced. Okay, here we're constantly increasing by 1. Okay, so make sure you check that first. Okay, if that's not consistent, then we're not even going to worry about the rest of it. All right, let's go on. These problems say, tell whether the graph of each quadratic function opens upward or downward, and whether the parabola has a maximum or a minimum. Now, when it comes to parabolas opening up or down, we know that we look at the value of a in a parabola. A is the number in front of x squared when that equation is in standard form. So all of these problems, all we're doing is putting them in standard form, looking at a. If a is positive, the parabola opens upwards. If a is negative, the parabola opens downwards. So let's look at number 4. Is number 4, is this in standard form? Yes, y is by itself, and we're going from highest exponent to lowest. Here we see that a is -1, a is the number in front of x squared, b is -7, and c is +18. Now, when we're looking to find if it opens up or down, we don't really need to worry about b or c. But let's look at this a. So once again, we see that a is -1, right? Since a is -1, that means that the graph opens down. Now, any parabola that opens down is going to have a vertex. Remember, the vertex is the point that is directly in the middle of the parabola. It's the highest or lowest point. The vertex, if it opens downwards, is going to be a maximum. Okay? So once again, our parabola opens down and it has a maximum. Let's go to number 5. Number 5, once again, you always want to make sure your parabola, your quadratic function is in standard form first. So we're going to add 2x squared to both sides to get that y alone. So that leaves us with y equals positive 2x squared plus 4x and plus 3. Here we see that a is 2, b is 4, and c is 3. Once again, all we're worrying about really is the value of a. Because a is positive, our parabola opens up. And if you have a parabola that opens up, we know that that parabola is going to have a vertex that is a minimum, because it's at the bottom of the parabola. All right, let's do our last one here. Here, we already see that y is by itself, right? However, one thing that you should be cautioned about is that you make sure that standard form also has highest exponent going to lowest. So if we were to rearrange these, we would have to put our -0.5 x squared first. So -0.5 x squared is first, and then that's a positive 5x. So plus 5x. So here, a is -0.5, b is positive 5, and c is 0. Remember, a is the number in front of x squared, b is the number in front of x, c is the constant. So here we see a is a negative number, so that means that it opens down. And like we said in the first part of our problem, if the parabola opens down, the vertex is a maximum. So we have a maximum for the vertex. All right, moving on. Number 7, graph the function y equals 1/2 x squared minus 2, then give the domain and range. I gave you a couple steps when it comes to graphing parabolas and graphing quadratics. First, you're going to find a, b, and c. So that means that your equation should be in standard form. A is the number in front of x squared. So here, a is 1/2. B is the number in front of x. Here, there is no x, so b is 0. And c is the constant. Here, the constant is -2, so c is -2. Now, once you find a, b, and c, you want to find the x-coordinate of your vertex. And that's found by the formula the opposite of b over 2a. Here, the opposite of b, opposite of 0 is 0. Over 2 times a was 1/2. So if I simplify that, that's 0 over 1, which is 0. So our x-coordinate of our vertex is 0. Now, many of my students wouldn't even have had to do the vertex formula on that one, simply because once you find out that b is 0, you know that this numerator is going to be 0. So it doesn't matter what a is, because 0 in the numerator of any fraction is just going to equal 0. Okay? So, but once you have your x-coordinate of the vertex, you always place that in the middle of your table. Okay, so we'll put that in the middle. And then we make values around that. So the values bigger than 0, and I always pick integers, are 1 and 2. Smaller than 0, the integers are -1 and -2. And then we're going to take these values and we're going to plug them in to our equation so that we can find our y's. Okay? So when you plug -2 in, -2 squared is 4, half of 4 is 2, 2 minus 2 is 0. -1 squared is 1, half of 1 is 1/2. 0.5 minus 2 is -1.5. 0 squared is 0. Half of 0 is 0. 0 minus 2 is negative 2. And I'm just going to go ahead and fill the rest of these values in, negative 1.5 and 0. Okay? Anytime your x values are evenly spaced, your parabola, your table, should be symmetrical. All right, all parabolas are symmetrical, but your table will be symmetrical if your x values are evenly spaced. So let's go ahead and plot our points. Negative 2, 0. That was our first ordered pair. Negative 1, negative 1.5. So here's negative 1. Negative 1.5 is about here. 0, negative 2. 1, negative 1.5 is about there. And then 2, 0 is here. Then when you graph the parabola, you plotted your points, you connect them with a smooth curve. So I'm just going to go ahead and make my little arms of my parabola there. So that was the first part. We graphed it. All right, I'm going to go ahead and erase the work here so that I can give the domain and range. So the domain for this parabola, remember, domain is a collection of all of the x values. This is my x-axis. So this domain, because this parabola is going to continue to go on and on forever and keep getting wider and wider, and is going to pretty much cover everything, we can see that the domain is actually going to be all real numbers. So we say the domain is all real numbers. All right, and that R with a capital R with a line through it is a symbol for real numbers. Now the range is a collection of the y values, these values here. Okay, so on our parabola, we see that the y's have a minimum of negative 2 and go up from there. So we can say that the range is all of the y values that are greater than or equal to negative 2. All right, great. Moving on. Number 8, this one says find the zeros of the function, then find the x-axis, then find the axis of symmetry. Zeros. This is another word for x-intercepts. Okay? So here we can clearly see that the zeros are here and here. What are those values? Negative 1 and positive 3. So those are the zeros of the function. All right. The axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. Here's our vertex. And the vertical line that goes through that vertex is here. Okay? So the equation for that would actually be x equals whatever the value for x is on this line. So the value for x on this line is at 1. Okay, so this is the equation for the axis of symmetry. Okay, x equals 1. That looks kind of nasty in there, but you get the point. X equals 1. So that's the axis of symmetry. Now, if I told you that, well, let's say that I didn't give you a graph, and I just told you that you had zeros of negative 1 and positive 3. You should know that your vertex is always directly in between your two zeros. So I could have said, okay, well, what is the number directly between negative 1 and 3? Well, that's like taking the average of the numbers. So if you take the average of two numbers, you add them together and divide by 2. Negative 1 plus 3 is 2. 2 divided by 2 is 1. So I know that the axis of symmetry would have had to be x equals 1. Okay? So that's how that problem works itself out. All right. Here, find the vertex. We talked about the vertex formula already, but the vertex formula actually only finds the x-coordinate of the vertex. It's your responsibility to find the y. So here, a equals 1, b equals 6, c equals 2. We know our vertex formula, the x-coordinate of the vertex formula, is opposite of b over 2a. Here, b is 6, so the opposite of b is negative 6 over 2 times a is 1. So this is, simplify it, you get negative 6 over 2, which equals negative 3. So this is the x-coordinate of the vertex. You take that negative 3 and you plug it in for the x's to find your y. Okay? So let's go ahead and plug that in. Y equals negative 3 squared. Don't forget, when you square a negative number, put it in parentheses. Plus 6 times negative 3 plus 2. Negative 3 squared is 9. 6 times negative 3 is negative 18. And then we're going to bring down that plus 2. 9 minus 18, this is negative 9. Negative 9 plus 2 equals negative 7. Alright, so our ordered pair for our vertex is negative 3 for x and negative 7 for y. Remember, the vertex is going to be a point on your parabola, so always be careful to put the x and the y coordinate. Alright, let's do one more of these. In fact, we might just go ahead and start this problem off. Whenever you do your vertex, remember you need to put it in standard form first. So your x, the highest exponent needs to go first. So that means this negative 2x squared needs to be your first term. And then we follow that up with the positive 4x and the positive 3. So here, a equals negative 2, b equals positive 4, c equals 3. Alright, and once again, you're going to plug it into your vertex formula. I'll just go ahead and finish it up. Opposite of b over 2a, opposite of 4, that's negative 4, over 2 times a is negative 2. So you get negative 4 over negative 4, which equals 1. You know what your x coordinate of the vertex is. Now you plug that in to get your y. It doesn't matter which one you plug these into because they're really the same thing. So I'm just going to plug it into our standard form. So y equals negative 2, x is going to be 1. So negative 2 times 1 squared plus 4 times 1 plus 3. 1 squared is 1. Negative 2 times 1 is negative 2. 4 times 1 is 4. And then I'll bring down that plus 3. Negative 2 plus 4, that is positive 2. 2 plus 3 is 5. So that's our y value. So our ordered pair for our vertex is 1 for x and positive 5 for y. Alright, great. Let's move on. Number 11. The height of the feet of the curved roof of an aircraft hangar can be modeled by y equals negative 0.02x squared plus 1.6x. Where x is the horizontal distance in feet from one wall at ground level. What is the greatest height of the hangar? Now, we know that because this equation that he gave us for the height of the hangar is a quadratic, we know that this is going to be a parabola. It's going to be a parabola that opens downwards because we see that a is negative. Now, the greatest height of any parabola is going to be the vertex. So all they're really asking us to do is find the vertex of this parabola, and we'll see that the value for y is going to be the height. Okay, so because x is the horizontal distance, we need the vertical distance. The vertical distance is represented by y. Alright, so let's just go ahead and find out our vertex in. So here in this problem we see that a is negative 0.02, b is positive 1.6, and c is 0. So our vertex formula, the x coordinate of the vertex is the opposite of b over 2a. Opposite of b in this problem is negative 1.6 over 2 times a is negative 0.02. If we simplify, that's negative 1.6 over negative 0.04. And let's divide that out. Negative 1.6 divided by negative 0.04 is 40. Okay? Now, once again, that's the x coordinate of the vertex. We want the height, so that has to deal with the y. So we take our 40 and we plug it in to the x's up here. Okay? So, y equals negative 0.02 times x squared. And x, once again, is 40, plus 1.6 times x. X, once again, is 40. So let's plug that in. Negative 0.02 times 40 squared plus 1.6 times 40 equals, this equals out to be 32. And there you go. So the height of the hangar, the greatest height of the hangar, is going to be given by, it's going to be 32 feet. Alright, I think this is going to be our last one. Graph each quadratic function. We're just going to do this one. Once again, we're going to make a table just like we did a couple of slides ago. So this is already in standard form. We find the value of our a, b, and c. Here a is 3, b is -6, c is +1. Find the x-coordinate of your vertex through your vertex formula, opposite of b over 2a. So opposite of -6 is a +6 over 2 times a. A is 3, so this is 6 over 6, which equals 1. Please don't think, oh, well, c was 1, this is 1, they're going to be the same. That's not always true. All right, so we're going to make our table, and we know that 1 is the vertex, the x-coordinate of the vertex, and that's always going to go in the middle. The vertex always goes in the middle, not the number 1, the vertex, whatever that is. The integers bigger than 1 are 2 and 3. Smaller than 1 are 0 and -1. And now we're just going to take these values and we're going to plug them into our equation so that we can find our y values. Okay? So I'm just going to go ahead and calculate these really quickly. You could pause the video and calculate these on your own if you need to. So the value for these are going to be, at -1, we're at 10. At 0, we're at 1. At 1, you're at -2. At 2, we're at +1. And at 3, we are at 10 again. All right, now my graph doesn't go all the way up to 10, so I'm going to have to improvise a little bit. So -1, we're at 10. So here 7, 8, 9, 10 will be about here. 0, we're at 1. At 1, we're at -2, so this is that point. At 2, you're at 1. And at 3, we're at 10. So again, it'll be about up here. So from there, we just go ahead and we connect it with as smooth a curve as possible. All right. And I know that that's not that smooth, but I'm doing my best. Don't judge me. All right, so there is our parabola. A couple things that you always want to check when you're graphing your parabola. Number 1, if a is positive, our parabola should open up, and ours does. Also C is the value, always will be the value of your y-intercept, and our y-intercept is 1 there, so that is correct as well. So we see that. All right, hopefully this lesson was helpful to you, and have a great day.